Good morning to all. My name is Himanshu Sharma and I am from Ujjain Engineering College pursuing my computer science BTech, and I am currently in my 7th semester. And today's presentation is all about MLOps with AWS SageMaker. And yeah, continuing with this. So what is CI/CD? CI/CD is also known as continuous integration and continuous deployment. It's a methodology to frequently deliver app to the customer by introducing automation into the stage of app development. Like the development stage of the app consists of various phases. Like the first one is build, testing, and merging, and then we are going to deliver it to the repositories where it is going to pass to the deployment phase. Okay, CI of this CI/CD section means new code changes to the app are regularly built, tested, and merged to the shared repository. There are various linter tools also that are going to go through the code, and their responsibility is to sanitize, and various steps can be performed over the CI stage. Coming up to the CD stage, this means continuous delivery or deployment to test and deploy on the live production environment, eliminating the business dev business teams communication gap. So all these processes is automated. So this is going to eliminate a communication gap between the devs request and the business requirement. And this is going to cut the time between the deployment as it is being automated in the CD part. This graphical representation is a very good overview of this CI/CD chain. Okay.
So, Himanshu, that means like whatever code changes I do in the code repository, immediately they are being tested and deployed to production, right?
Yeah, CI/CD is a kind of ideology which we follow. Continuous integration to the repository until and unless a developer publishes his changes, the uh, the integration step wouldn't be initialized. As he publishes his changes, there are certain steps like building, testing, and merging, applying linters, analysis over the code. Then it is going to be published in the repository. From there, it can continue with the build stage and delivery stage.
Yeah. So all these steps are automated through pipelines, right?
Like we are independent of choosing what kind of tool set we use. We also have GitHub Actions, Jenkins to implement CI/CD. And for this MLOps, we are using SageMaker because it is a all-in-one kind of tool that offers building, deployment, and monitoring also. So
yeah, Himanshu, before you go to the next slide, I would like to throw you some light. Can you please throw some light on what is MLOps first of all? Because we are all getting into MLOps and you have directly started with CI/CD. So before
yeah,
that, if you throw some light on
the minute
MLOps.
part, I will go to it on future slides.
Sure, sure.
Okay. So what are pipelines? CI/CD pipeline is a series of steps that must be performed in order to deliver a new version of the software, but using automation. CI/CD is a concept, and to implement it, we use pipelines. Pipelines are just a term coined for the functions that we perform throughout the CI/CD cycle. First, it is the planning phase, then the coding phase, then build, test, release, deploy, operate, and monitor. This is a continuous cycle that is an ideology which is being implemented by pipelines. This is the term which you have to keep in mind. So now, as Sir said, what is this MLOps? The elephant of the room. It's a DevOps is a method of developing, and CI/CD is a method of implementation. And MLOps stand with the same idea but DevOps focuses on the software development, but MLOps focus only on machine learning components. MLOps is narrowed to machine learning steps, components, and implementations, where DevOps is a very broad field of application development. As you can see, the components of ML ops structure are being listed here. It is the ML code itself, the analysis tool, data validation, data collection, configuration, serving infrastructure, feature extraction, process management, and machine resource management, monitoring tool. So these are the major components that are being implemented in the ML op development environment. And SageMaker is, as I said, is all-in-one kind of tool for us that enable us to implement all these components within from one control set.
Yeah, so Himanshu, I would like to add a couple of lines here. So this particular block diagram which is on your screen currently has some background actually. So this original block diagram was used by Google in its original paper on MLOps. So they have a very famous research paper on MLOps through which they introduced many new concepts and MLOps terminologies, the CI/CD, and many new concepts they introduced through that research paper. And in that, they wanted to show whatever coding you do on a Jupyter notebook of developing the best model and optimization, whatever coding you do on the Jupyter notebook is the overall part. So its overall percentage is whatever is being shown in that this block diagram. So that is the ML code block diagram which you see it is shown in different color. And all other diagrams are shown as per their effort. So service infrastructure here has the largest effort. Feature extraction is one step in which is having some amount of effort. So the size of block here is representing the size of the kind of effort which is required in that step. So you can compare all these steps with the coding step or model development stage which you do in the Jupyter notebook. So in overall MLOps cycle, ML code is a very small percentage, which you can see, like if you can add all these boxes and assume that it is making up 100%. So ML code is a very small percentage of code development, or model development is a very small percentage of overall machine learning development cycle. So this diagram size, more importantly, this block size are proportionate to the effort required in that particular step. So you can see that data collection is a larger box, and after that service infrastructure also is a large box. So that's where you need more time, and then feature extension, and then so you can see that almost ML code is the smallest of that particular percentage of that effort. So ML code is almost, you can say that smallest or the second smallest box. So you can see in proportionate how much effort is we can spend, how much effort we generally spend in developing the code, developing actual model. So all these blocks, all these boxes are in proportionate to their size. So it has a big history actually, and almost everybody nowadays, whatever presentations I see on MLOps, they invariably use this particular diagram to explain you what is MLOps and what is the percentage of ML code development in overall development cycle of machine learning. Yeah, please, all yours.
So as sir said regarding the comparison of the ML, that is very correct, I guess, and it added to the quality to this presentation. So coming up with next, what ML Ops offers. So as we know, what's the reality of market? We have shortage of data scientists who are good at developing and deploying scalable web applications. So ML Ops helps here. Reflecting changing business objective in the model is what MLOps is best at. As the business requirement change, the continuous integration and deployment character of this MLOps procedure is able to help us to adapt to the changing demand of the business need. Removing communication gap between technical and business team. As you know, the CI/CD also include deployment phase. So plus it is automated. It can be done manually, but the plus side is it is done by automating all the processes. This is going to eliminate the communication gap and the coordination gap between the technical and the business team. That is being said, the supplier and the receiver end. This gap is being fulfilled by MLOps. Due to the black box nature of machine learning and deep learning systems, models often tend to drift away from what they were intended to do. Assessing such risk can be predicted via MLOps. As you know, machine learning is a very kind of research-based work, and particular problem need research concentrated to its implementation only, as it cannot be derived from another in a full-fledged manner, and the solution for one problem cannot be directly implemented for another. So as the problem statement changes, our requirement also changes. This causes the solutions to be more specific toward them. This may lead to them being very vague and difficult to understand. This may lead to future biasness or variance in their prediction set. This is being countered in MLOps by deploying a monitoring phase in the CI/CD chain.
Yes, so again, Himanshu, thanks. I want to add a couple of lines here. So here in machine learning systems, like once you deploy any software, so it is lifelong, suppose software there is, assume that it rarely happens, but let us assume that in your software system, there are no bugs. 100% it is bug free. Then what happens? Whatever your software you have deployed, like a railway reservation system, like you have deployed once, you need not change its logic. You need not do any changes into the software because it is bug free. So assume it is bug free. Then you don't need any effort in the software maintenance unless your business logic changes. Assuming that business logic is not changing and there are no bugs, that means for next 5 years in your railway reservation system, you need not make any changes. But it is not like that in the case of machine learning and deep learning systems, which we deploy. Machine learning models tend to bias tend to increase. Like what happens? Whatever data you train on X amount of data, and then your predictions you are making on continuously with data which is continuously coming to you. So data is unseen data. So suppose the nature of data changes, so the accuracy of your model decreases. So that is called model drift. Okay. So whatever the kind of, there was one kind of data on which you trained, and you trained your systems, and then that kind of data is not coming in the future. So your predictions go wrong actually, and your accuracy of your model decreases over the time. So you need to train and retrain continuously. You need to retrain your model. Okay. So new kind of data, whatever new data is coming, you have to put that into historic set, and say 1 week you have X MB of data. X plus 2 weeks, 2 weeks from then, whatever the data is collected in 2 weeks. So again, you may have to train the model after 2 weeks. So I'll take example in our company. What is happening is, one example I will take. So we have a random forest model deployed for supply chain predictions. So like demand predictions, we have a machine learning model, which is deploying random forests. Okay. So what happens every week when the data comes, the data is fed to that model on every Friday night, and Saturday night India time the model runs. So what happens? Whatever data is coming into that particular last week, the data came. So that data is put into historical data, and every week that model retraining happens. So it is not like that once you once you train the model and for a long time you can take the advantage. It is not like that. It is continuously you need to train and retrain your machine learning model. So that is typical with the machine learning systems. And I have heard about some machine learning systems of maybe either Amazon or Google, I'm not sure. But one of them, like Amazon or Google, every hour their models on their websites are getting retrained. Every hour. And unless this data pipeline, like all CI/CD pipelines, whatever steps we have seen so far in the previous slide, whatever steps like Himanshu has shown. So unless these steps are automated, fully automated, 100% automated, training full hundreds of model, and there are hundreds of model on their website. It's not only single model. Hundreds of machine learning, different machine learning models are there, and all the models are getting retrained every hour. So unless a very high level of automation is given, is attained, it is not possible for to achieve this every hour retraining of training and retraining, training and retraining. So in 24 hours in a day, 24 times their model, hundreds of their models are getting retrained. So assume that there are 100 models, and every hour if you are retraining them. So how many training cycles are there? 2,400 training cycles per day are there. So this kind of automation can be achieved only when your pipelines are highly automated. So that is what is the whole objective of your MLOps. And that's what we are going to learn through this hands-on coding and in this particular theory course which Himanshu is taking up. Yeah, Himanshu, please, all yours.
Thank you, sir, for that. So now, what are the phases of MLOps? In general implementation that we have seen, that we have done on our basis, it's moreover to collecting data and then making a model and creating predictions, analyzing it by some analysis method of, say, confusion matrix. But for MLOps, it's moreover to a business need fulfillment process. First is framing the ML problem from business objectives. It's the reason why we are using ML. If there is no specific business need, then it has no use in the real world, I guess. So now architect ML and data solutions for the problem. What kind of ML algorithm and what are the sources of data? What kind of data is it? We have to analyze. Maybe in some case we are using a stream processing, and in some cases we have batches of data being supplied to us. So that need its own specialized kind of algorithms for what kind of ML we need to use over there. Then comes this stage of data presentation and processing. Data is usually unstructured and is lacking in its consistency. Most of the time of the development phase of any particular machine learning objective is spent over the data presentation, preparation, processing, and gathering. So the first three steps are the major one that specifies what kind of business need we have, what kind of ML we are going to use, what is the data source, and the preparation process and processing. This result in a structured data that the ML can understand and train upon. Then we have the stage of model training and experimentation. As we have seen, models do have their quirks in them, say hyperparameter tuning, the size of data they are working upon, the quality of data they are receiving, may it be a stream or batch. So these factors are affecting the kind of model which we are using and their prediction qualities. This need extensive research over them, and we have to develop a comparative study that fulfills a business need at the most. Then building and automating ML pipelines. We first manually produce certain results, and if we are satisfied with them, then we are going to produce the automated pipelines, as we have discussed what pipelines the MLOps uses under CI/CD. Those are going to be fully automated. So as the new data comes, it is able to train upon it and deploy continuously over the deployment machines. So now, the second step, deploying model and the to the production system that we already discussed. And next is monitoring, optimizing, and maintaining models. As Sir said, for as uh, that example for real world implementation, what Amazon usually do with its machine learning model, we have to continuously optimize it so that it doesn't fall into a biased category, and it is able to fulfill the business need, even though it may be slightly changed, but it is able to adapt to it. This can only be achieved if the pipelines are fully automated and they are being analyzed on the production phase only. Sorry, on live cycle, live prediction cycle. Okay, so these are the major phases of what MLOps covers. What AWS SageMaker offers to us. SageMaker, as I've said earlier, is a all-in-one solution that offers gathering data, storing data, building models, deploying them, and monitoring them. And this is the basic structure over the implementation side. As you can see, the deployment and hosting phase and the model training phase, that is under the SageMaker group. This result in deployment of models that are particularly stored in their EC2 bucket, the EC2 instances, and the data that is being accessed throughout this process of deploying, training, artifact storing, feature extraction. All these steps are being saved to a particular S3 bucket. And the control flow is going to be discussed in future presentations. But this is an overview of what kind of implementation does the SageMaker offers to us.
Yeah, so just add to whatever Himanshu has told, whatever the steps ever you look at, so from feature engineering stage, feature extraction, feature engineering stage, till model training, retraining, deployment, and then again in the full cycle. So one we observe any drift in the model, like accuracy is decreasing. So then what we see, we again take the historical data and retrain the model, and again deploy it, and then again analyze it whether it is producing adequate results or not, like producing satisfactory results or not. So all these stages which you see in block diagram, so are fully automated within SageMaker itself. So all data is taken in and out from S3 bucket, and all the model artifacts like the trained model. So all trained model is also stored in S3 bucket itself. Okay, and all the deployment of model that happens is on EC2, like EC2 container. EC2 is nothing but your Amazon cloud. So on Amazon cloud we deploy our model, and all the data and all the model artifacts are stored in S3 bucket. And all these pipelines and all these steps, right from feature extraction till deployment and analyzing the model, retraining the model, everything is fully automated through feature like through different pipelines. And we'll have when we'll do coding hands-on, sorry about it. So when we'll do coding hands-on, we'll have a very close look at how these pipelines do work in practice. Yeah, over to you.
Yeah. So for a general example, as you can see, if we start with a stage that when we have a model being deployed to a particular machine, and and the client is using it. So the real data is being stored as a training set. It is going to be passed to the training phase. Then the trained model are going to be stored in the model artifacts. And there we are going to perform certain checks, like is it fulfilling my requirement of say mean squared error, is it fulfilling the threshold of say accuracy or recall in it, and then we are going to select the best out of it, which is going to be deployed over the machine, and we are going to produce inferences out of it over the real world implementation. And this cycle goes on, the frequency can be changed of this cycling as per your business requirement. So coming up to the example to using it, we are going to use the example that is being given to us by the AWS SageMaker itself. It's a very popular one, predicting the age of an abalone by using certain feature set. So for this example, we are going to look into the example that is available to us in SageMaker itself. Abalone dataset predict age of an abalone using the given feature set, processing the data, training the model, and then deploying it are the tasks that we are going to cover in this example. Abalone example is about age prediction, as we know, where abalone is a shellfish. It's a sea creature that is more over like in Hindi we say CP. Okay. At its core, it's a regression model using its feature. Okay, the abalone data set contains the length of the organism, the diameter of the shell, the height, the whole weight, the sucked weight, the weight of its meat, the viscera weight, the weight of the organism after the blood is drained, the shell weight, that the weight of its cell, the sex, it may be a male or a female, and the number of rings on the shell. As you can see, it's clearly visible to us. Okay, so this is the example which we are going to see, that is going to show us how we deploy a model. Sorry, how we extract the data, pre-process it, then train the model, and then deploy it to a particular EC2 instance, and using its inferences from there. So these are the component in this Abalone project that we are going to see. This include the pre-processing of the Abalone data, because as you can see, there are various features and they might be unstructured or say not normally distributed. So we can apply various scaling methods. Encoding, as you can see, the sex would have been definitely male or female. So we have to apply certain kind of encoding, may it be one hot or a label encoding. Okay, so that is going to be processed in the pre-processing step. Then the model is going to be trained, then evaluated, like with respect to the validation data set. And then we are going to check the MSR, the mean MSR that the model is going to give to us. If it satisfy a particular criteria, then we are going to register the model and save its artifact. From there, we are going to deploy it over a particular instance. In more technical terms, this is a DAG, directed acyclic graph, that shows flow of control throughout the steps. For this, we are going to train a XGBoost model using the dataset. This XGBoost algorithm is offered from AWS algorithms library, because we are using container-based implementation. So Amazon already gave us the implementation of all these algorithms that abides to their execution requirement. Okay. And once the training has been done, we are going to evaluate through the MSR and then register the model for the further deployment. Okay. Is it okay? Okay. So now we are going to see the file structure of the Avalon project. We are going to see the project on the SageMaker itself, but this is something which you have to keep in mind before going over there. As you start with the project, we will be presented with a root directory. There we have a pipelines directory in which we have the Avalon directory that contains the init.py, the pipelines, and the pre-processing.py. The main hero of all this project is the pipelines.py. He has all the information regarding the pre-processing, training, deployment, and what kind of inferences, how we are going to use them. All stuff is being stored over here. This is the main point that we are going to utilize. If say I have a real business need and I want to use SageMaker, then my changes will particularly start from other stuff like the cold bit specification.yaml. This is thing which we alter only if we have highly specific business need. Okay, in general we do not need to change rest of the stuff. Only things that fall under the directory Avalon are the stuff that we might alter with changing business. Pre-processing.py is something that carries the code, and the utility is how the data set is going to be pre-processed, either to apply a label encoding, one hot encoding, or scaling methods to say like robust scaling. Okay, so this is the general overview which I want to give to you. And the moment you change something in these files, say pre-processing or pipeline, say you change the type of instance in the pipeline, say it may be T3X large bucket and you change it to T3 medium bucket, and you have to publish it to the repository. As you publish, the CI/CD cycle will kick in. Though it may take some time, but it is going to start in the back. AWS offers with various facilities of code repositories, code build, and deployment, and all these things are being implemented under this CI/CD as you publish your changes. And the model will be trained, and it will wait for your approval in the experiment section, which we are going to see in the SageMaker interface in itself. As the user approves it, it is going to directly deploy itself over the deployment instances. Okay, so for diving down to the code, we will discuss in later on classes that is going to be held on Sunday. Yeah, and
Yes.
in that we are going to discuss what kind of libraries, what kind of implementation intensive details are required. We are going to look into them in the next class. May it be as how to access S3 bucket, authentication flow, and the pipelines, what kind of instances we are going to use. All the minute detail we are going to cover in that in the next class.